Okay, I think we can start. And meanwhile, if people want to join, they're welcome to join. So I hope I'm audible clearly. So I'll just introduce myself for those who couldn't attend the last session. My name is Ganesh Ramaswamy. I'm a PhD scholar. I'm working under the guidance of Professor K. Ramesh, who also happens to be offering this course on the SWAYAM portal. And my co-guide is Professor U. Sarunan from the Civil Engineering Department. I'm pursuing my PhD in the Department of Applied Mechanics at IIT Madras. So I welcome you all to this problem solving session where I would urge you all to, there are some sample problems which we will be solving, and I would urge you all to solve along with me. So I'll be solving it live. I urge you all also to solve it along with me. And whatever doubts that are there, we can take it in the chat box, or perhaps we can unmute and ask. If that becomes too messy, we can perhaps take it in the chat box. And in between, we just have some couple of multiple choice questions. So I'll just create a Google poll. I launched the Google poll, and you'll be able to see it on the right side of your screen. In the Google Meet screen on the right side, you'll be able to see a thing called activities, where there'll be a square, triangle, and and a circle. So you'll be able to take the poll from there. It is just a poll to give. I'll give four choices, and you can select which one you think is right. Based on whatever response comes, I'll perhaps try to, if there is a deficit, I'll try to address that in the understanding, and we'll go about solving the problems. So I apologize that last class while I was solving, there was some, as you're aware, there was some problem with my pen, so I couldn't proceed with the last problem as I had promised. So I'll be taking up that problem first. We'll be going through that a little quickly, and then we'll move on to the problems from week 2. And should there be any questions, you please collate them and feel free to ask them. Also, I would like to emphasize that we also have a forum where you can ask the question on the Swayam portal. When you go, you can see a button called Ask a Question. If you click there, you can join that forum. You'll be receiving updates from whatever responses we give to the learners when they raise the query there. So perhaps there are multiple ways for you to approach us with any residual doubt, so that a clear conceptual understanding is built. So with that background, I think we can get started. So we'll look at the first question. It says a flagpole is supported by two cables, AC and AB and AC as shown. So this is A. Here we have A here, B and C. And it is known that the magnitude of tensions FB and FC in the two cables are given to be 600 and 750 newtons that they have given. So based on the data given, we are supposed to answer this question. Now the length of the position vector of point B with respect to point A is asked. So basically first we have to write the position vector. So as we had discussed, there are many ways to go about it. First is that you can see that the XY and Z axis are emanating from the bottom of the flag post. So for convenience, let us take that as point O. That is the origin of our coordinate system that is given. So what we want is the vector R B with respect to A, which can be given as R B with respect to O minus R A with respect to O. As someone had also pointed out in the last class, that why don't we simply sit at A and look at B and fix the origin at A and state it right away. That is just cutting one step short, so that is not a problem at all. You can do that, but in the interest of clear understanding, I'm just going from the first principles. So first we have to write RB with respect to O. What would that be? From O, how would we reach RB? How would we reach the point B? So we will have to traverse this distance, which is 2, in the plus x direction, and then we have to go to point B, which is minus 6 in the negative y direction. So it is clear that RB with respect to O becomes plus 2 I cap minus 6 j cap, and we can clearly see that point B lies in the xy plane only, so there would be no z component. For the sake of completeness, we can just write that it will be 0 k cap. Similarly, if we were to take RA with respect to O, we can see that we just have to go 8 meters up the pole from O in order to reach point A. That is 8 meters along the Z direction. So x and y components naturally become 0. And if we were to subtract this, since we have written it in component form, it is easier for us to simply subtract the scalar components and we will get the final vector. So RB with respect to A would come out to be 2 I cap. We subtract these plus, sorry, minus 6J cap minus 8K cap. So we have got the vector. Now what they are asking is the length. So we know that for any vector, the magnitude represents its length. So the magnitude of R D with respect to A is asked, which we can easily calculate as 2 squared plus minus 6 squared plus minus 8 squared, which comes out to be 10.19. So many people had already solved this problem because I could not write, so I was just showing them a glimpse of the problem, and they were able to solve. In a similar vein, just for completeness, I'm solving this. If we were to go to the next question, in a similar fashion, we have to write RC with respect to A. So for this, we would take another approach. Let us sit at A directly and try to write what C would be. So we are able to see that sitting at A, we would have to traverse a distance of plus 3 in the positive x direction, plus 2 in the positive y direction, and then we have to come down by 8 meters. So this would directly be plus 3I plus 2J minus 8K cap. And we can also approach it by first principles as we did RC with respect to O, RA with respect to O. RA with respect to O remains the same. RC with respect to O we will have to write and subtract it out. So the length of this vector is again given by its magnitude, which would be comes to root of 77, which is 8.77 meters. So this is the answer for this. Now yes. Mayuresh Bole, you have any questions? Hello, Mayuresh. Okay. So could you would you mind me? Yeah, thank you. Okay. So now coming to the main question, if FB, see FB is written in bold. So you please take note that a vector can be represented as bold, or it would be represented with an arrow, or in higher studies we would also see that it would be represented by a tilde or an underbar as it is called from in continuum mechanics and subjects like that. So this is just a for the sake of convenience, they represent it in different forms. There is I think it would be clear as you go ahead in the course, but I suppose this is a vector is what we are supposed to identify here. So FB is represents the tension in the cable AB. This is FB, and its vector form is asked. So we know that cable can take only tension. It cannot take compression because it doesn't have stiffness in that direction, and it cannot take bending either. So it can take only a pull. So FAB is the tension along its length only. So we have already calculated the vector along its length. Now we know that for any vector, it has an associated magnitude with it and an associated direction with it. This is what is asked. And based on our discussion just now, FB's unit vector would be same as RBA's unit vector. So we have been given magnitude of FB, which is given as 600 newtons. So all we need to do is multiply it with the unit vector FB, and we will get the components of FB. So the unit vector of FB is same as the unit vector of B with respect to A, which as we saw here, this was the vector we got, RB with respect to A, and its magnitude came out to be 10.19. So if I was to keep it here, this is RB with respect to A, we have got. So the unit vector would be that divided by its magnitude. So if we have to calculate FB directly, it will be 600 into 2 by 10.19 I minus 6 by 10.19j minus 8 by 10.19 k cap. And if we calculate this, we'll be able to get the coordinates directly. So this comes out to be 10.19 if I take. This will be 117.76. Second comes out to be minus 353.29. And third is, it would be higher because vertical is more. So it is minus 471.05. Okay, so we can just write it in its final form because finally we will have to add this is FB vector. FB comes out as 117.76I minus 353.29J minus 471.05K. And since I've already given this derivation in detail, for the next question, that is this we have already got. Let us put it here. Okay, so this we have got. Now similarly FC we have to write. FC would be 750, which is the magnitude as it is given, into the unit vector. What is the unit vector? We got the length of FC was the length of RC with respect to A, the length of that position vector, which came out to be 8.77. And components we can directly write from here itself. So X is 3 by 8.77I plus 2 by 8.77J minus 8 by 8.77 K cap. Here we will directly get FC. So the idea is I'll do one part of it in detail and the second part we'll just, for the sake of brevity, we'll cut it short and we can do it quickly so that we are able to solve more problems. And should there be any questions midway, you please note them and we can discuss them after the question, after solving this problem. After 750. Yeah, anyone had any question? So it comes out to be minus 683.76 K cap. 3, sorry, this would be, I suppose that is what that message was about. 750 into 3, so this will be 256. I'm sorry about that. This is 177 and it is minus 683. So I suppose that is all right. Now I'll take this and put it here. Okay. So in our next part, what we are asked is what is the magnitude of the resultant force? So basically it is the same as adding up these two forces vectorially. So let us take this to be the vector resultant. So it will come out to be 374.31 I cap minus 182.25 J cap minus 1155.41 K cap. So what will be the magnitude of this? It is straightforward to calculate. It comes to 1228.13 newtons. Now if we look at the options, we have the closest 1227. That might be because of some rounding errors, because I have taken the absolute, the entire decimal. So that way, if we see, the closest answer is 1227. I'm sure if you work it out only with the two decimal places as given in the instructions, you will be. So a little bit of rounding error is what has caused this difference. But essentially, this is how the problem is to be solved. And let us just look at the last part also. What is the inclination of the resultant force with respect to the x-axis is what is asked. So how will you calculate the inclination between two vectors? That comes from the dot product, projection of one vector over the other. Let us say this is a vector A, and let us say this is a vector B, and we have an angle between them. Let us call it theta. So what will be the angle? How to find out the angle is basically coming from the definition of the cross product, dot product. It is given as A dot B is given as magnitude of A, magnitude of B, and cos theta. It is basically projection of one vector over the other. So if we were to invert this, we will get cos theta as A dotted with B upon magnitude of A to magnitude of B. So with this background, theta we can calculate by cos inverse of that, the entity we get on the right side. So what have we been asked? We've been asked the resultant force. What is the angle it is making with the x-axis? Let us first copy the resultant force. This is the vector we have here. Okay. So this is the vector we have here. Now this begs the question, what is the second vector that is to be considered in order to calculate the angle between them? We have been given that it is the x-axis. So we basically have to consider a unit vector in the x direction. What will that unit vector be? Call it B. Call that vector B. What will it be? I cap plus 0 j cap plus 0 k cap. 1 I cap. So that there is no confusion. This is the second vector that we have to dot it with in order to find that inclination. So if we were to dot these two, what would we get? I dotted with I is 1. I dotted with anything other than I is 0. Same thing goes for J and K also. So we would find that this top portion A dot B, as we will see FR dot B, so cos theta comes out to be 374.31 dotted with 1, which is 1, and the rest of the components go to 0, divided by the magnitude of that vector. Now we can see that magnitude of B is 1. It is not necessary that we have to take only a unit vector in I, because anyway we are normalizing it. If you see, this is nothing but a unit vector in that direction. So I have already taken 1, and 1 divided by 1 comes out to be 1. If you take a bigger magnitude, let us say you took a vector that was along the x-axis. Let us say you took it to be 5 I cap plus 0 j cap plus 0 k cap. You will anyway be dividing by its magnitude. So it is equivalent to having a unit vector in that direction. That is why for brevity I took B to be 1 initially. B to be 1I initially. Divided by the magnitude. Magnitude we just calculated, it was 1228.13. So what will theta come out to be? We are getting it as 72. 72.25 degrees. And in the exams and assignments also, you are requested to carefully read what are the units that the question asks you to answer in. So there is a possibility that you might have to substitute the angle in radian, or you might have to enter the angle in degrees. Since here all the options are given in degrees, it is pretty clear. But nonetheless, this is something you should be aware of, because many a times we solve the entire problem and it doesn't pay dividends, because at the end we are reporting some answer that. Now coming to the last question, and then we'll take up questions based on this, and then we'll move on to questions on equilibrium, week 2. So which of the following options is correct? Options. So there could be more than one option also correct here. Is correct with respect to the force system at point A as depicted. So what is the force system at point A? We have two forces like that. Those are the only two forces that are applied at point A. Are they concurrent? Yes, because they say that It is applied at a, it is applied at a point, so it has to be concurrent. Is it coplanar? This is something to be thought about. Are these force system? Is this force system coplanar? Is there a plane that can contain these two forces? We can see that the plane ABC, if I were to draw it like crudely like that, this plane contains these two forces. So essentially, it is coplanar. Is it a body force? We can see that it is tension, that is, it is applied. At that point, it will be pulled by some means, it will be connected. It has nothing to do with the body force here. And are they collinear? We can see that they are not collinear. Both the, if they were collinear, R B with respect to A and R A with respect R C with respect to A would have been parallel. Needn't be pointing in the same direction, but they would have been parallel. So if you want to make sure in the future, if you are given two vectors and asked whether they are collinear or not, what is the condition for collinearity? The angle between them has to be 0 or pi. Either it should point in the same direction or in the opposite direction. So we have one recipe to calculate the angle between two vectors, which is the dot product. So you can just dot those two vectors and see what is the angle that is coming in between them. If the angle comes out to be 0 or pi, that means they are collinear. So with this, I suppose this question is over. I can take up any doubts or questions that are there and then proceed to the next problem. If they are there, you please feel free to unmute and ask, or we can use the chat box also if you are uncomfortable. Yes, yes, doctor. Sorry. Okay. Yes, yes, sure. So we have two forces, FB and FC, that are applied. So we, by vector sum, we have some resultant force that is there. What is asked is what is the project angle of that resultant force with the positive x-axis. We in vector algebra we generally have the dot product and a cross product. The dot product gives you a scalar and the cross product gives you a vector. Dot product by definition it is given as this: a dot b is ab cos theta, magnitude of a, magnitude of b cos theta. Now we have one vector which is the force resultant. We have been asked its inclination with respect to another vector. Now it begs the question, what is that another vector? That another vector is along the x-axis, we know that because we have been asked the angle with respect to the x-axis only. Now what is any vector that is along only the x-axis? It will have only I component. Other components go to 0. Now what would that I component be? We can take it to be any value. You take it to be k, some k constant. We have we have one vector that is going along the I direction. Let it be scaled by any scalar. Let its length be k. Now you dot our force with this. You will get the projection. When we divide it, we are already dividing by its magnitude. So this vector which we considered of length k, it automatically gets normalized to a unit vector along the x-axis. A unit vector along the x-axis is 1 I cap plus 0 j cap plus 0 k cap. That is why I dotted it with this. So this force, we have three components. Now if I were to dot it with uh, 1 I plus 0 j plus 0 k. What would this dot product? Dot product is multiplication of the corresponding entities. So it will be 374.31 into 1 plus all go to 0. On the bottom, we have magnitude of two vectors. The second vector happens to be a unit vector. So you needn't divide it by 1. It is identically the same. So you just need to divide it by the magnitude of the force that you got, which comes out to be 1228. And that is how you have calculated the angle between them by taking cos inverse. Is it clear? Whosoever, I hope this answers your question. Dr. Zoya Fatima, you had, uh, yeah, Yeah. These, the one that I'm writing down. Yeah, yeah. This PDF we will be sharing. This will be a PDF or in some Google slide or something we will be sharing subsequently. And also, yeah, yeah. So these we will be sharing, and also this meeting which we are having currently, that also I'm recording. So it will be broadcast, and the Swayam people will be taking care of that. And soon there will be some place where it will be uploaded, and uh, all the students will be informed. Okay, okay, yeah, okay. Any other question? The person who had asked this doubt regarding the angle, is it clear? Could you just give me a confirmation? I forget who that was. Was it Arupratan Gupta or you had asked the question? Is it clear? Were you the one who asked the question? Okay, okay, all right, all right. Okay, so we will proceed to the next problem for equilibrium because the last class problem we just solved now. So this is a simple problem first to start with, because the idea is not to solve a complex problem and the idea is to solve fundamental problems with which we get the first principles and the basic ideas, and those we will develop subsequently. And the assignments of the course are also designed in a way that it will be increasingly made tough, so that the conceptual development is sound. Okay, so we have this question: a box W has a mass of 10 kg and is supported on two massless strings AC and AB. AC and AB. These are two massless strings whose lengths are fixed, which is why they are in this configuration. And they are supporting this weight W. So, what is the magnitude of the tension given that this is in equilibrium? It is a given because we are dealing with the subject of static equilibrium as of now. So, it is to be taken that these are in equilibrium. And what is the magnitude of the tension is what is asked. So, here we will apply something called the sine rule. In case you have not come across this, it is better to brush up sine rule and cosine rule, because these will be extensively used in dynamics also in order to find any absolute velocity. In absolute motion, cosine rule will be invariably used. So it is better to brush up these concepts clearly. So if sine rule basically deals with the three sides of a triangle. If you were to take a triangle such as this and call it A, B, and C, the three sides, and call it alpha, beta, and let this angle be gamma. So the sine rule basically says that A by sine beta is C by A by sine beta is C by sine gamma is B by sine alpha. It is just the side and the opposite angle it is subtending. So the opposite angle to side B is alpha. The opposite angle to side A is beta, and the opposite angle to side C is gamma. I'm sorry, the I drew the circle, the triangle a little smaller, but I hope you're able to catch what I'm trying to say. So, with this background, we know that these ratios are fixed and are equal. That is what is important here. Now, we have 10 kg load, but the answer is asked in newtons. So, we have to be careful here. We have to multiply it by g in order to get the force in newtons. Amar Bagban, you have a question, Mr. Amar Bagban? Yeah, thank you. So, and then we have a force here, which is FAB, and we have a force here, which is FAC. Again, we know that these are strings, these can take only tension. So, the direction of the force will be along its axis only. So, this is theta. This is given to be 60 degrees. The same thing we can also cast it like this. If three different vectors were there, if this was B, then this would be alpha. If this was C, then this would be gamma. If this was A, then this would be beta. if we just separated out the triangle and make them concurrent, this is how it will come out to be. You can try it yourself. So we have a similar force system here. We know that this is 90 degrees, this is 90 degrees, and this would have to be found. Now theta is given to be 30 degrees here. Okay, so this is 30, that is 60. So naturally this becomes 90, this angle. So what would the sine rule give us? It will be 10g by sine 90. I may as well not write it, it is 1, but nonetheless for completeness sake I am writing it. So FAB by, what would it be, sine of 60 plus 90, because this total angle we have to take from FAC to 10G, whatever angle is being made, that is the opposite angle subtended by FAB. That is what will come here. And here it will be FAC by sine of 30. Actually, it will be 90 plus theta, but since theta is 30, it will come out to be like this. So now we just have to solve this ratio, and we'll simply get the, because one quantity is given, two are asked, and we have two ratios. So we can trivially calculate FAB. FAB comes out to be 10G. So it is 10 into 9.81 is what we are supposed to take. It will come out to be 49.05 newtons. And FAC comes out to be 84.95 newtons. These are the answers to this question. Now we have something interesting constraint here. Now it is given that the maximum tension, that string AB, this string, the maximum tension that it can sustain without breaking is 75 newtons. So we have been given what FAB maximum is. Okay, and this is some other configuration where theta is 40.9. This theta is given to be 40.9. And FAC has not been qualified, and we know that it is at the same angle because nothing has been mentioned so far about that. So what is the maximum weight in newtons that can be supported without breaking this string is what is asked. So the constraints have changed a little bit. We have W as the weight that is being supported. We have FAB max, which is given to be 75 newtons. And this is applied at an angle of 40.9. And this is again right angle. And we have FAC, which still for our purpose is unknown at this juncture, because it will not be the same. Since FAB has changed, naturally FAC also would have changed. This is 60 degree, this is again 90. Now this angle, this is no longer a right angle, so I should be drawing it like that. This angle, call it say delta, sorry about that, call it delta. Delta is 180 minus 60 minus 40.9. Now we have been asked W. So W upon, if we were to write the sine rule again, sine of 180 minus 60 minus 40.9, which is nothing but sine delta, is equal to something we have been given. FAC we have not been given, but FAB maximum we have been given. So 75 by, that constraint remains the same, sine of 60 plus 90. This 60 and this 90. So from here we can easily calculate what would be the weight that can be supported without breaking the string. Sine of 60 plus 90. So comes out to be 147.29. So I urge all the people who are attending to parallelly solve it with me, because this will engage you more, and it won't be dry. So it will be something in case there is any error, because I'm also solving it live. In case there's any error, you will be able to quickly catch, and we can avoid any problems there. And you also will be engaged throughout the session. So this is a simple application of sine rule. The idea was that we start from the fundamentals, we get an idea about what are the basics, because generally, as I had also told in the last class, it so happens that it's not that we lack the entire concept. There are generally very small gaps that get left out, which is why we are unable to approach some problem or get to the bottom of it. So this session only serves to address those gaps, because otherwise the subject has been well taught by the lectures itself. The idea is application of those concepts which we have learned into these problems will help you identify those gaps and fill them. So that is what this initiative is all about. So I urge you to ask any questions. Stop me and ask me questions midway also. That's fine in case you have, so that you make the most out of this session. Okay. Are there any questions regarding this problem? I'll be happy to take any questions. Otherwise, we will move on to the next part. If there are any questions, you can either type it in the chat box or you can unmute and ask. Okay, understandably, because so we have been dealing with vector resultants and these simple problems for a long time. So I suppose it is right that you are not having questions, but in case you do have, please don't hesitate to ask. Okay, as I had mentioned that I will be creating a poll. You can just type in which is the answer that you think is right for this question. The question says the following equations were satisfied when applied to a system as a whole. We took a system and then we applied these two equations. What are these two equations? These are, you notice that F and M are bold. As I have mentioned, if something is mentioned to be bold, you take that it is a vector. Either that, or you will have a, either it is bold, or you will have an arrow, or you will have a tilde, something like that. It is a matter of convenience when they are actually writing books. So they generally, authors, they take up different conventions. But these are vector equations. Okay. So a system was taken, and on a whole, sigma f external equal to 0 was applied, sigma m external equal to 0 was applied, and it was found that that system as a whole, globally, it satisfies those equations. However, these conditions were found necessary but not sufficient to conclude that this system, which we are talking about, was in a state of equilibrium. In such a case, what could that system have been? Could it could it have been a perfectly rigid body? Could it have been a deformable body? Could it have been a point mass? Or could it have been a system of interconnected rigid bodies? So I'll just start that poll. And there could be, it may so happen that there could be more than one answer also possible for this. So in that case, whichever you think is right, any one out of the two or three or four you think is right, you can just fill it. One thing I can tell you, that all the four are not the answers. This question has a maximum of only two options correct. I'll tell you upfront. So you just select any one of the two that you think is right. I've launched that poll. I hope you guys can see it on the right side of your screen. You can just go to activities and you can just fill in whatever the answer you think is right for this question. Okay, we have people filling in. Yes. Okay. All right. And mind you, the question is asking it was found necessary but not sufficient. Yeah. So I'll just take it for five more. On the count of five, I'll stop the poll, and then we can take it from there. Okay. Okay. I can see that many of them have got it right, but seems to be a little bit of confusion. So I'll just explain that. We take a system, and then we found that sigma f external, the vector sum of all the forces, came out to be zero, and sigma external of all the moments, external moments that were applied, came out to be zero. But still, it is found that for some reason, this system, we cannot conclude that this system is in equilibrium, because although these were necessary conditions that were satisfied, but these were not sufficient to conclude it. So what could that system have been? Actually, the correct answer is it could have been a deformable body, or could have been a system of interconnected rigid bodies. Why? Because we have taken this as a system as a whole. So this I would just like to emphasize a little bit as to what this thing is talking about. Let us say I have one aluminium piece. For all practical reasons, for this subject, I consider this to be rigid. Although this is deformable, we will consider, for the sake of this explanation, I'll consider this to be a rigid body. Now I'm pulling this on both the sides. With, let us say, I'm able to apply equal forces. And globally, I'm seeing this. This is not moving. Although I have applied external force, this is not moving. This is still in equilibrium, because you're not seeing it move like this, you're not seeing it rotate like this. I'm just pulling it like this, and it is in static equilibrium. So, and this has satisfied. I have applied two forces on this body. I have applied two forces. Say that I have applied it equally, and we are not able to see that this is moving. So acceleration is zero. So the sum of the external forces is zero, that it has satisfied globally. And some of the external moments, I have not applied any external torques on this. I have only applied two forces at the ends. So this is also trivially satisfied. In which case, is this sufficient to conclude that this is in equilibrium? Of course, I saw that I am able to pull it, but it is not moving. It is in equilibrium. So if I consider this to be a rigid body, then definitely the condition that external forces, vector sum of the external forces and vector sum of the external moments equal to zero is necessary as well as sufficient to conclude that this body is in equilibrium. Now, if I were to take a deformable body, let us say the same thing, I'm taking a rubber band. Okay. Now, say I'm applying the same force here. You are able to see that it is deforming. We are able to see that the point of application of the force is moving away from each other. In which case, I observe that I have still applied only two opposite forces, for which the vector sum is zero, external zero. I have not applied any torques. But is this in equilibrium? No, we are able to see that this is not in equilibrium. Why? This is a deformable body. So for deformable body, although these conditions are necessary, without these, I cannot even go into analyzing it. Although these are necessary, but this is not sufficient to conclude that this is an equilibrium. We have to ensure that this is satisfied or each and every conceivable subsystem, which is where, if we see in higher studies, we will be taking a small portion of it, and the internal stresses and things like that will start coming into the picture when we deal with equilibrium equations of deformable bodies, which is out of the scope for this current course. But this is the reason why it is necessary but not sufficient. Now, coming to a system of interconnected rigid bodies. If I were to have interconnected rigid bodies, because we are saying, we have qualified the question saying that as a whole, these were satisfied. But internally, what is happening, we don't know. If there were a link like this and there was another link like this, let us say, you imagine that there are two links and both are pulled externally by that same force. we will be able to see that although this thing there could be still some internal movement possible. In which case, the condition should be for every conceivable subsystem. What are the conceivable subsystem in a system of interconnected rigid bodies? Each of the rigid body. Each of the rigid body has to satisfy this. That is, if there are 5 links that are connected, unless and until each of the 5 links are themselves in static equilibrium, we cannot conclude that the whole system is in static equilibrium. This is the essence of this question. I hope you have understood it. And if there are any questions, you please raise them here. I'll be happy to answer them. So it is clear. Okay, that's good. Okay, so we'll move on to the next question then. Are there any questions in the chat box? Okay, no. All right. So we'll move on to the next question. And this is the last question for equilibrium, just to get a hang of the subject well. So we have two perfectly circular logs that are placed in an inclined plane pushing against the vertical wall. So we have a vertical wall like this, and we have two perfectly circular logs, wooden logs that are pushing against this wall, and they are placed on this incline. Each of the log is exactly 3 meters long. Long means it is the length is out of the plane of the paper, is what they mean. So there is a log like that, and this length is what they are calling as 3 meters. 3 meters. Both are equally long. So it is known that for this variety of wood, the mass density is given to be 0.75 kg per meter cube. That is for each volume of this wood, each unit volume of this wood, each meter cube of this wood weighs 0.75 kgs. So how much will this be in newtons? Because all our questions have been asked to report it in newtons. So naturally it will be 0.75 g newton per meter cube. Now if we were to calculate the weight of this log, because essentially we have to calculate all the forces. For a free body diagram we need the weight. So we need some more information. A line drawn perpendicular from the center of these logs to the plane to the plane BC. This is the plane BC. So this perpendicular line, the length of this perpendicular line is known to be 1 by root pi meters is what is given. So essentially what they are trying to say is the radius of this log, of this perfectly circular log, is 1 by pi. So naturally we can calculate what the volume is then. It is pi r square L, which is the length, into the mass density of wood. Weight density of wood would give us the weight in newtons. So into 3 meters into 0.75 g is the weight. So what is the weight of one log come out to be? So these two will cancel out. We'll get it to be 22.07 newtons. Okay. So now what have we been asked? For an inclination of theta equal to 40. All are 40. Everywhere they have given theta equal to 40. So this theta is 40 degrees. The magnitude of the reaction at point C, the magnitude of reaction induced at point B and point A, and what is the magnitude of force applied by from one log onto the other. That is, at this contact point there will be a force interaction. So magnitude of that force is asked, and then we'll come to this question later. First let us deal with this. So we have to draw the free body diagram of the two logs. Let us take this to be a circle. Let us take this to be the other circle. Let me draw it a little better. Let me just copy this. Okay. So if we were to draw for the upper log, we know that this is W. its mass, its weight will naturally act downwards. What else do we know? This there is a point at A which will have reaction, which will offer a reaction at A. So basically friction we are ignoring here, although I'm sure while taking a snip I might have missed it, but this question basically does mention that uh, you know uh, friction is to be ignored for this question as of now. When friction will come, when we will be dealing with week 6, there friction will come. We will also try to solve similar questions where this is involved, friction is involved. So we have RB which will pass through the center. Okay, and then we have RC. There is one more force that we need to account for, that is at the contact point of these two. Let me just pull this away here. At the contact point of these two. Now let us say that this top log will naturally be pressing down on the bottom log. So we will be having a force like that. Let us call this log 1. Let us call this log 2. So F1, 2. F due to 1 onto 2. Or if there is a confusion, we can say F2 applied on F due to 1. By Newton's third law, we know that this will be equal and opposite applied F1, 2. So we have got the free body diagrams of all the both the logs. Now if we have to solve, initially we see that log A, log 2, I'll just copy again, I'll paste it here. Log 2 we are able to see that this is unknown, this is unknown, this is unknown, and this is unknown. W is known. So there are basically 4 forces out of which one is known. But in order to apply sign rule, we require at max 3 forces because it comes from the triangle law. So if you were to consider this, if we don't have to go for the sign rule, then we will have to write out the components and write vector equations. But we'll try to solve this using sign rule. So if we consider this, now I know that F12, these are two perfectly circular logs. So this distance is same as this distance. It is 2r and both are parallel lines. So naturally at the point of contact, the force that will be applied F12 and F21 will be parallel to the plane BC. So it will be at the same inclination as the essence. So we have W here and then we have F12 which has the inclination which was given to be 40 degrees. This is 90. Now we have another this thing. We know that the radius, the perpendicular distance is what was given. So the radius would be perpendicular to plane BC, which means we have RC here and this angle would be same as theta. So this would come out to be 90 minus theta. Theta is 40. So this will come out to be 50 degrees. And this is again 90. So 50 and 40 again make 90s, which make these two perpendicular, as we have seen from the diagram also. So now it is just a trivial thing to write down sin 90 is RC upon sine of 40 plus 90, which is equal to F12 upon sine of 50 plus 90. W we know, we have calculated this here, 22.07 is what our W is. So naturally using this we can simply calculate what RC is. So RC comes out to be 16.91 newtons. This RC, considering these two ratios, the first and the second ratio. If we were to consider the first and third ratio or the second and third, since we already know second now, we can simply calculate. So 22.07 into sine of 50, 90 plus 50. This comes out to be 14.18. So F12 comes out to be 14.19 Newton. Okay. Now we know these two quantities. Now if we were to consider this free body diagram here. Now I know this F12. F12 is equal to F21. Only it is in the opposite direction, marked on the other body, and we have already put it in a direction that was opposite. So it just happens to be 14.19 Newton, the magnitude of that force. W is known, but still here there are four forces, so we cannot go with sign rule. So we will have to write out the components. So let us bring it to the center. We have 14.19 and then we have 22.07. Then we have RB and we have RA applied like that. If we were to bring everything, transpose all the using the principle of transmissibility, if we were to transfer all the forces to the center of that log, this is the diagram we will get, where this is 50 degrees, okay, and this is 40 degrees. I hope that is clear. Why that is? Because the force will act along this line and this is parallel to this. So it has the same inclination, which is 40. So this is 40. Now, if we were to write out the two equations, what would they be? I'll just copy this. I'll put it here. Now, let us say this is the positive x direction, this is the positive y direction. If we were to write sigma fx equal to 0, what will we get? Ra minus Rb cos 50 minus 14.19 cos 40. This doesn't have a horizontal component, so that is all. The second equation will be along the vertical. Ra will not have any component along the vertical. So 0 plus Rb sine 50 minus 14.19 sine 40 minus 22.07 equal 0. So these are the two equations that we need to solve in order to we have two equations and we have two unknowns. So this is what we are required to solve. Sorry, I'll just write it again. Pardon me. From the second question, there is only one unknown. Or from the second equation, there is only one unknown. We can directly calculate what this is. Into sine 40 plus 22.07 by sine 50. So this comes out to be 40.72 Newton. And if we were to substitute that into the first equation, we'll get this as 37. Ra as 37.04 Newton. So with this, we will be able to solve this question. Coming to this last question, now they have said that theta is unknown. What is the angle? What is the inclination angle theta in degrees such that the ratio of the reaction induced at B to that induced at C is 1.5. So what is the constraint that they have given? RB upon RC is 1.5 is what they have given. So what will happen is when we try to solve this, the first sign rule, it will be in terms of RB. And then when we substitute that into the second equation, we will be able to solve for the unknown force that way. And finally, it will come in terms of theta, because here we will not be putting 40, here we will be putting theta. So finally, you will get an equation in terms of sine theta equals something, and then from that theta you can back calculate. So I would encourage people to take down this problem and perhaps try to solve it on their own. And if there are any questions, you can always raise it in the forum. And anyway, we will be having these sessions every week on Friday at 6 o'clock. So you are more than welcome to join every week and perhaps ask this question. In case you have any difficulties, you can definitely ask. So that's about it from my side. If there are any questions regarding this, I'll be happy to answer. Anyone has any questions regarding how we solve this or anything at all? Or even from week one, if you have any questions, you're welcome to ask. So everything I've discussed so far is clear. Okay. Okay. So I take it. Yeah. Anybody that is there moment occurring on the logs? Is there any moment occurring on the logs? Okay. See, it's a good question that you have asked this. We can see the free body diagram and you just analyze this. From the principle of transmissibility of the force, we have delivered everything to the center of the log. So it is a concurrent force system. So concurrent force system can it support any moment? Because moment is basically what? R cross F. In a concurrent force system, R cannot exist. R is a zero vector there because you are not transferring it to any point. It's a zero vector. Hence, even if you were to do sigma m equal to zero, it will be trivially satisfied because it's a concurrent force system. It's a very good question that you have asked. I hope that has clarified your doubt. Arupratan Gupta, I hope that has clarified. Any other questions? I'll be happy to take questions. Yeah, yeah, absolutely. In this live class, and you're also welcome to ask them in the forum. Either way, we will try to address that. You're more than welcome to ask. Any other questions? Yes, sir, it's okay. Thank you. I understand that after this COVID time, everybody has been, doing online classes, and it becomes a little dry over time because you just hear somebody talking and solving. So it would be in the best interest that you also solve it along with me, so that you're able to get the confidence in case there is some deficiency there. And whatever doubts that come in, it is always easy to ask it just there and get it clarified rather than wait and post it in the forum and all that. So I would encourage you all to ask doubts in case you have any. I hope my delivery is fine. So in case there are any issues with that also, you are more than I would welcome some feedback on that also if there are any. Other than that, this is all I have for week two. We will be meeting up next week again on Friday, 6 o'clock. As discussed, it will be the same Google Meet link throughout the semester. So I encourage you to join and ask as many doubts as possible. I suppose because force systems and equilibrium is generally dealt with in the in the school level also up to a certain extent, there aren't many doubts coming up. But as we'll move on to trusses in the next week and beams in the subsequent week after that, that is when, because those are new concepts that students learn. So there'll be more questions that are stemming up. So I encourage you all to ask as many doubts as possible, and I'll try to answer them in this session. Other than that, if there are no further questions, I'll call it a day. Thank you.